Here's another look at the problem we just did. It may be an easier way to do it. Um, as I've said, they're not going to have you do this with integration on this year's exam, but you can still use what you know, even though it's not being tested. So we're still going to look for total distance, and we know that total distance, if you remember, from 0 to 3, would be the integral of the absolute value of the velocity. Make sure you're writing absolute value. If it was net distance, you wouldn't use the absolute value. So I decided this is our position function. I really didn't want to take the derivative because it's going to involve a product and a chain rule. So I went to Wolfram Alpha, and Wolfram Alpha seems to be down today. So, and it was down for a little bit yesterday too. So just be aware of that. So it turned out I'm going to have to actually take the derivative. The derivative is a product rule. So I did the first times the derivative of the second. You have to use the chain rule for the sine of t squared over 2. So outside, inside, plus the derivative of the first, which is -1, times the second. So it really wasn't that bad of a derivative. So now I'm going to integrate this velocity, the absolute value of the velocity, from 0 to 3. So calculator, hit the absolute value. I didn't simplify because why bother? Let my calculator do all the work. So I basically just typed it in exactly how I wrote it with the derivative. Second calc, integrate, and look, notice the graph is always positive, so that because I put absolute value signs around it, it looks good to me. The lower limit is 0. Oops. Start that over again. The lower limit is 0. The upper limit is 3. So this integral is 9.5599. 9.5599. If you compare it to the last, that's pretty. 9.559 is what we got from the last part. It was a little off, but that's what happens when you're doing derivatives, when you have the calculator do derivatives for you. But there's an alternate method.